The majority of planets we know orbit a host star. These planets, including Earth, all receive heat and light from their parent star. It is also the light emitted by these stars that enables humans to observe and detect them. But there are invisible planets, hidden from our sight, silently drifting and abandoned in the vast universe. Those dark and lonely worlds have no host star to hold them in orbit, no light to bask in, and no warmth to radiate. Yet, the likelihood of these rogue celestial bodies existing is far greater than we ever imagined. Cold, lonely, and still, yet capable of nurturing life. They are planets with the potential to develop life. These orphaned worlds have been given many different nicknames: pseudo-planets, rogue planets, sometimes even called wayward planets. Planets form from the debris left over after a star is born. They orbit the young star in a thin disk filled with particles of matter and gas, gradually growing through a process where small particles collide, stick together, and attract one another. This process continues until they have cleared all the surrounding material from their environment. In this universe, everything is inherently chaotic, and collisions between planetary embryos, also known as infant planets, are extremely common. Stars do not typically form in isolation but rather in large clusters comprising hundreds or thousands of stars simultaneously. It is the interactions between young planetary systems within these stellar clusters that will trigger even more violent episodes of destruction. The early Earth is believed to have collided with a Mars-sized object, and this impact ejected enough material to form the Moon. But other planets face an even bleaker future. On average, each star in our Milky Way galaxy has approximately 10 planets orbiting it. However, this number only reflects planets that have existed and have been observed by us at the present moment. In the evolutionary journey of a star system, countless worlds are formed, but not all can remain intact to this day. Some will collide and merge with other worlds, forming larger ones. Other stars will gradually lose energy due to gravity and be pulled inward, most likely plunging directly into the central star. Over time, these worlds interact with each other through gravity, causing the planets to gradually shift into the most stable orbits possible. Typically, the largest and most massive worlds tend to settle into their most stable configurations, and the price of this stability is often paid by other, smaller and lighter worlds. In the brutal war for survival among planets, the most common outcome is for the defeated to be expelled from the solar system and cast adrift into the interstellar void. According to supercomputer simulations, for a solar system similar to our own to form, at least one gas giant and approximately 5 to 10 smaller rocky planets must be ejected into interstellar space. There, they will wander throughout the galaxy as rogue celestial bodies. This currently suggests that the number of rogue planets without a host star is roughly equivalent to the number of planets orbiting stars. But these are merely orphan planets. They once had a common home, orbiting a host star, but were eventually torn away from their parent star due to gravitational forces from their sibling planets. A large portion, or one could even say the vast majority of rogue planets, do not have a parent star at all. To understand the reason, we must travel back in time to the very beginning, when the first stars in the universe began to form. Whenever there is a large, cold molecular gas cloud, it fragments and contracts into numerous clumps. Within these clumps, gravity acts to pull the mass inward, while radiation acts to push it outward. If a gas cloud is sufficiently cold and large enough, at the core of its densest regions, it can reach the necessary temperature and density to trigger nuclear fusion, thus forming stars. In a star-forming region, a fierce race is underway between gravity, which constantly strives to produce as many massive stars as possible. And between radiation bursts, this activity blows away gas, halting the growth of gravity. When observing a newly formed star cluster, the naked eye can immediately discern that gravity has prevailed, as a large number of massive stars stand out distinctly. However, this conclusion is essentially a deception. For every hot, blue, massive star we observe, there are in reality hundreds, even thousands, of smaller stars. T emit light dozen. For every 5 stars in the universe, 4 are red dwarfs. Low-mass stars with only 8% to 40% of the Sun's mass. But the most easily observable stars actually have masses dozens, even hundreds of times greater than that of the Sun. When these giant stars burn fiercely and shine brilliantly, they blow away the clouds of gas that are the raw materials for forming new stars. Not only do they prevent these low-mass stars from growing further, but they also hinder the gravitational growth process of young stars in their path. If you consider the entire mass of a molecular cloud before it forms stars, you'll find that 90% of its mass returns to the interstellar medium. Only about 10% of the total mass of matter constitutes stars and planets. The most massive stars form the fastest. They then blow away the leftover gas over millions of years, simultaneously preventing the formation of any new stars in their path. This leaves the cluster predominantly composed of low and medium mass stars, while also producing a large number of stars that cannot fully form. These clouds of matter never reach the necessary threshold to form a star. Although these clumps of matter never formed around a host star, they still have the size and characteristics that fit the physical definition of a planet. According to a 2012 study, for every star born, between 100 and 100,000 rogue planets are also formed. The fate of these planets is to drift eternally through the dark interstellar space. They may be massive gas giants, but they are more likely composed of rock and ice. Notably, many of these planets are filled with all the essential ingredients for life. From our solar system, we can see the icy moons orbiting the giant planets far from the Sun. For instance, Europa, Ganymede, and Callisto may also harbor subsurface oceans and could potentially be habitable. The water on these moons is not heated by the Sun's warmth, but is instead warmed by internal friction generated as they are stretched and compressed by the gravitational pull of their host planets. If a world could become habitable without relying on sunlight, a surface, or an atmosphere, why do we only limit the search for life to Earth-like worlds orbiting stars? Scientists believe that rogue planets could also potentially harbor life. Being eliminated from the star system early does have at least one upside. The intense ultraviolet light from young stars cannot penetrate the dense atmospheres of these planets, which helps them retain heat. A research paper published in 1999 titled, "In the Vast Expanse of the Cosmos, Planets Capable of Sustaining Life" have given rise to a hypothesis that the dense atmospheres of rogue planets not only prevent internally generated heat from radiating out into space, and could also maintain surface temperatures warm enough to sustain long-lasting oceans, similar to those on Earth. Some terrestrial microorganisms can still thrive vigorously under such extreme conditions. However, life on rogue planets would still have to be a miraculous occurrence. By harnessing the planet's very small intrinsic energy source, compared to over 99% of the Earth's energy, which originates from sunlight. If a rogue planet has a sufficiently large moon accompanying it, the planet could be heated further through tidal mechanisms. Similarly to the relationship between the moon and the Earth, when the moon formed over 4.4 billion years ago, it is now about 15 times closer to us. This phenomenon causes a strong warming tide. Scientists believe that the moon may have played an extremely important role in transforming the primordial Earth into a habitable place, even if such a warming process only occurred over a few 100 million years. It can provide a far more abundant energy source than the rogue planet's own heat. To predict oceanic processes, it is necessary to construct geological models with complex structures, and can create favorable conditions for microorganisms to multiply and thrive. But what are the chances that rogue planets have their own moons? Nick Ober, a researcher at the Captain Institute of Astronomy and TEO Def. Based on the original passage, the sentence appears incomplete and lacks a subject. Below are some of the most natural and clear ways to rewrite it, depending on the context. Theoretically, it is entirely possible for an artificial satellite the size of the moon to exist around and around a wandering planet. Based on the simulated trajectory results, more than 47% of the moon's surface may still bear the gravitational influence of gas giants expelled from the solar system. Similarly, simulations also show that Earth-mass planets were ejected from the system. More than 4% of them still retain satellites comparable in size to the moon. Beyond the possibility that rogue planets might retain their moons, they and their satellites also have the capability to directly combine with each other. From the clouds of gas and dust in the universe, among the stars, just as among the stars in the sky, scientists have discovered rogue planet candidates surrounded by a disk of material. From that point, moons similar to those orbiting Jupiter could have formed. Researcher Vaticio Travio Avila, an expert on rogue planets at the University of Concepcion in Chile, stated, "Planets have many natural satellites, with Jupiter's Galilean moons being a prime example. Even the ability to retain those moons after they are ejected from orbit is higher. Similar to the warming phenomena observed on the moons of Jupiter and Saturn. On some icy moons, subsurface oceans have formed. Satellites orbiting rogue planets could also harbor subsurface oceans. If a rogue planet retains multiple moons and they maintain elliptical orbits, the warming process due to the tidal effect is likely to be sustained. And along with that are the deep subsurface oceans beneath the surface." Cassini spacecraft flew through the plumes erupting from Saturn. It has found various organic molecules, which are the building blocks of life. Cassini spacecraft observations suggest that hydrothermal vents may exist in the ocean on the moon Enceladus. It is possible that life exists similar to that found in hydrothermal vents in the deepest, darkest regions of Earth's oceans. Various microorganisms, such as metanosens, not only thrive near above-ground vents like these. Scientists also believe that this may very well be the way life on Earth formed in its earliest days. According to the hypothesis, microorganisms could exist deep beneath the ocean floors of icy moons. Like Enceladus, rogue planets are also meticulously protected. To avoid the impact of asteroids and harmful radiation, it is protected by a thick icy shell on the outside. Another possibility is that it might resemble Saturn's moon Titan, which possesses a very dense atmosphere. A sufficiently large moon of a rogue planet could also possess a similar atmosphere. Along with the warming of Titan, these outer moons have a mass comparable to Earth's. They may have temperatures high enough to sustain surface oceans for hundreds of millions of years, and creates favorable conditions for microorganisms to thrive. With all the life-bearing potential they possess, it is difficult to detect rogue worlds in our galaxy using traditional exoplanet observation methods. Although rogue planets are quite common, at least one of them might exist just about 10 light-years away from us. But we haven't found any planets yet. In 2013, scientists captured the first direct image of a Jupiter-like rogue planet candidate. 80 light-years away from us, yet it is difficult to distinguish it from a class of objects known as brown dwarfs. Failed. 14 other rogue planet candidates have been discovered by applying a technique called gravitational microlensing. In this phenomenon, a planet's gravitational field bends the light emitted by objects behind it, thereby amplifying and extending the observational range. However, verifying the results still faces many difficulties. The detection via gravitational lensing is a one-time event, making it very difficult to observe them. It is difficult to distinguish a faint brown dwarf from a rogue planet, as this technique favors the detection of more massive objects. Next-generation space telescopes, such as NASA's James Webb or the soon-to-be-launched LOTO by the ESA. It is possible to detect satellites the size of the Moon and Titan orbiting rogue planets and brown dwarfs. Upcoming large-scale surveys by NASA's Nancy Grace Roman telescope will open up many new opportunities for discovery. Similar to surveys using gravitational lenses, they will become increasingly more effective in the future. The discovery of rogue planets along with their orbiting moons will open up opportunities for scientists to conduct deeper research. If life exists on these worlds, it will likely be the most common form of life in the universe. And who knows, perhaps we ourselves are the strangest form of life in this universe.